Hello everyone, welcome back to my channel Datacraft by DPP. Today we are going to walk through a simple architecture pattern in data analytics in Azure. I don't want to overload you with too many topics here. I would like to take a simple architecture pattern and then see how we take the decisions based on the requirements that we have. Let's get into it. So let's say, for example, there is a customer, or you are an interview, there is a customer that says he has a retail company, and then in that retail company, they are going to produce one, maybe 100 million records per hour. And the business users for this particular use case is two types of business customers. The first kind is store managers who wants to see the operational dashboards every 15 minutes. And there are second set of customers who are data scientists who wants to use this data, consume this data to train some machine learning models. So even the data scientists also want the latency 15 minutes. So if someone asks you to design or build an architecture for this kind of a platform, so how do you approach? Let's get in there. We want to understand more about the approach. We really don't want to talk about the technologies or the tools that we are going to use. We will cover that, but my this whole video is not about the technicalities of what we choose. Instead, as an architect, how would you choose an approach? What kind of things you keep in your mind before you start creating an architecture? Okay. Let's get in there. So that is what, if you look at this picture, if you look at here, so the SLA is 15 minutes. Both store managers and the data scientists, they want to see the data within 15 minutes after it is generated, the data is generated. So that is called as a near real time. Anything is in between 10 to 15 minutes of latency, we call it as a near real time. Anything within 5 seconds or less than a sub-second, we call it as a real time. Here, based on the use case, based on the customer requirement, the latency is 15 minute. SLA is service level agreement. So we have two users, store managers, who wants to see this data every 15 minutes with different operational dashboards. It could be Power BI or it could be Tableau report. On the other side, we have a different data scientists, machine learning people who wants to consume this data to train the data against different machine learning models, and then based on that they generate some patterns using machine learning feature stores available in any one of these cloud technologies. So today I'm going to use Azure and Databricks as my tools and technologies, because this is the beginning series of my architecture patterns. So we are not going to complicate this whole design today. So let's go ease, and then we just take basic topics and tools and technologies, and based on that we start adding complexity to it, and then we can go beyond that. So whenever you are asked to build or you're asked to design or frame the architecture for any data analytics platform, before we jump into what kind of tools we use, what kind of patterns we follow, we need to understand the requirements first. Every customer expects you to understand their requirements. So when we talk about the architecture requirements, there are always two kinds of requirements: the functional requirements and non-functional requirements. The functional requirement is all about who, what, how. Who is like, who are the people or who are the consumers are going to use your data. In our case, the consumers are store managers and data scientists, and how they want to use the data. The next question is how, right? So how they want to make use of this data. In our case, The store managers are going to use any dashboards or reporting platforms, which can be Tableau or Power BI or in-store any reporting tool or technology. And then third concept is how. How do they look at this data? And in this how scenario, so what kind of data we are going to provide? Are we going to provide the raw data? Are we going to provide the clean data? Are we going to give the data that is reusable? So all these things are coming into the picture right here. So that is basically the functional requirements part. So basically who is going to use my data and how they're going to use what they're going to use, like what in the sense, either it could be raw data or it could be clean data, or it could be curated form of data in the form of a star schema or snowflake schema. And then once we are clear about the functional requirements, we also need to understand what are the non-functional requirements. So these are super critical and important for any architect who is going to build a data analytics platform, because the non-functional requirements talks about availability, retention period, scalability, disaster recovery, and service level agreements. Availability in the sense, let's say for example, um, the customer is looking at the dashboard and then he's looking at live data for every 15 minutes, and there is a location there is a failure at one particular location, and the system is not able to process those records. So do we need to how do we get this data processed so that the customer won't lose any of his productive time? So that means that is availability. Do I have the system always available for me to work on? So that is availability. And retention period. What is retention period? Retention period is how long we want to keep our data with us. You cannot keep the data forever, right? You cannot keep the data for 20 years, 30 years, 40 years, 50 years, maybe 100 years. You can keep, if you have resources available and if you have that much of money available. But in general scenario, in real life, that's not going to happen. So because retention always comes with some cost. So you need to store the data in your hard devices or in your cold storage devices, wherever it is. You need to store the data, and the storage comes with a cost. So that is why before we draw anything, before we come into any conclusion, it is always better to get that requirement from the user, how long they want to keep the data. That is retention period. And scalability, let's say for example, on few days my store sales are not that much aggressive. Sometimes the user, say let's say if there are any long weekends or any festive offers, any long weekend deals are going on, then people keep buying stuff from your online store. That means your traffic will be more records keep coming, and then the load on your whole system will be doubled or tripled, or even sometimes 10 times more than or bigger than normal workloads. So in those cases, how do we make sure our entire pipeline will take that load and then process the data as it process the regular data within a minimum latency and with a lighter load? So that is what scalability is. Scalability is something like we need to keep adding the resources so that the system performs in a way, in faster way that user or consumer expects it. So that is what this whole page talks about. It's full of the architecture requirements. So my best suggestion for anybody who is giving an interview or who is really starting to design any architecture in their projects, the first thing to understand is, the first thing to remember is you always need to understand what are the requirements, both functional and non-functional requirements. Without having any knowledge about these requirements, it's not gonna help you at all. And then the second thing I would like to do as an architect in my project or any project I'm going to take up, I'll do some back of the envelope calculations. So if you remember in our first slide, the requirement is like, this particular retail application is going to produce 100 million events or messages per hour. So we need to understand how much of storage it's gonna take, how big of this whole event processing load is. So let's say, for example, when you start talking about the events or messages which is coming from front-end application to your databases or your data lakes, it's not just the whole size of that whole thing. Like, you need to store this data. I'm going to talk about the Medallion architecture in a moment. So when you say Medallion architecture, your data is being stored in bronze layer for raw data, and silver layer for transformer data, and then in the gold layer for the curated data. So when you have three layers of storage, you need to keep all the raw data in your branch, which is in the raw form, and then some of the data you apply the deduplication, and then you store the remaining, I mean the same copy of the data with the deduplication, maybe less number of records if you remove the duplicates, and then you store all of the data into silver layer that adds additional storage, and then the curated data will go and sit in gold layer, which is going to take another copy of this data in gold layer. So when you're talking about this much of data, you're going to keep this much of data in your bronze, and some of the data in silver, and some of the data in gold. Again, if you want to replicate this data for disaster recovery purposes, let's say in two different locations, so you need to multiply by 3 of this whole data size, and then you will have to save some data on the disk for dimensional tables, and you need to keep some storage for the metadata as well, and you need to keep some data for delta log and everything. So for that you may have to do some additional storage for this data. So in total, if you combine all of that, definitely your data is gonna be 4 or 5 times much bigger than what you fundamentally receive from your source application. So now let's look at the data calculation here. Excuse me. So let's say, for example, in your input data, if the application or the retail point of sales is generating 100 million events per an year, and let's say for each message or event is 0.75 kilobytes average. So that means it is going to be 75 GB gigabytes of data in an hour. That is for an hour. Then if you multiply that amount by 24, it's gonna be 1.8 terabytes, and 1 terabyte a day is going to be 54 terabytes by month. Okay, because we are multiplying it that amount, that number by 30. And then if you look at the overall size of this data for an year, it's going to be 650 terabytes of data. So we are talking about the raw data, which is 650 terabytes. Then some of this data will go sit in bronze, and then silver, and then gold, and then you kind of add metadata on top of it. So it's gonna be 2.5 petabyte if you consider the replication and the retention period. So now just understand how this, when you design or architect for a data analytics platform, this is the important step that you need to remember, because whatever you store in your entire data platform is not what you just got it from your front-end application. It is many times of that data with the different layers being added to it. So because of that reason, so it is always better to do the back of the envelope calculation and do the capacity planning to understand how much storage is gonna cost you, and based on that your retention period requirement will change, your replication requirement will change. And if client is or your customer is very particular about these things, you need to understand this whole concept of capacity planning, and based on that you need to start allocating the resources, whether it's a compute or storage or monitoring, all of that. I hope. You get the gist of it. So now we know the functional requirements, and now we know the non-functional requirements as well. And then we looked at the volume of the data we are going to deal with. And then next thing is ingestion. So in our application, we have the retail point of sales is our source application. But in general, it can be many sources of data. Either it could be CRM data, it could be IoT devices data, or it could be sensor data, or it could be change data capture data from a different databases that we already have in our projects. So it could be n number of sources, but whatever may be the source, your ingestion architecture is gonna follow similar pattern. So like I said, we are not going to complicate this particular architecture in this video. We want to make it simple and easy, and then we start adding the complexity to it in the subsequent videos. So for this particular application, I'm thinking to use Azure as my cloud. Okay, we will talk about AWS in a different video, but for now, let's keep it simple. So in this particular scenario, we are going to use Azure Cloud. So for this kind of a load, like 1.8 petabytes of data, or that is for the storage. Let me take you back. So for 1.8 petabytes of data, or whatever it is, for that kind of a size, let me go back and then see what size for. Uh, Okay, 1.8 terabytes of data per day. Okay, and 54 terabytes of month. Let's say, for example, we look at 1.8 terabytes of data per day. Okay, because we are looking at the latency requirements 15 minutes, right? So for 1.5 terabytes of data, either you could go to Kafka streaming application, or you can choose Azure managed Kafka compatible streaming source, which is Azure Event Hubs. So when we talk about more complex pipelines, we'll cover the Kafka part of it. Kafka is open source event streaming platform, but for this particular workload, it needs it kind of its own setup, which is gonna be a overhead layer on top of this. That is why we are not covering Kafka in this section. So what I'm gonna do is we are going to use Azure Event Hubs, which is Kafka compatible type event hub. So we are going to use Azure Event Hubs for this explanation. So every time you kind of receive data from front-end applications or source to Azure Event Hub, or Kafka kind of a streaming platforms, we need to define the schema registry, because there is a concept called data contract. When a producer is sending data to our application, and we being the consumers, we want to make sure the schema is properly registered, because we want to get an agreement on the schema, because the producer register the schema, and then we use the schema, we validate the schema, and make sure all our events and messages are following that schema. Because if we don't have a proper schema, then one record come in different schema, and the next set of records comes in a different schema, then it is very hard for us to maintain this data with the different schemas for each batch of the input load. So to avoid that overhead, we always want to register schema, and have this data contract agreed between the source, the producer and consumer parties. Sometimes what happens is, if the incoming record is in compliant with the schema that we registered, the data will be ingested and processed in the downstream applications. Let's say, for example, there are some records coming with a failed schema or damaged schema. So in that case, we have to identify those records, and we send them into dead letter queues, DL queues, which are a separate tables that collects the malformed records in terms of schema definition. So that is why we use dead letter queue concept here, so that there is always for us have a chance to go back and then see what are the messages or events coming with wrong schema or malformed schema, we can go back to the producer and ask them to resend or replay them, or we can ignore them if that is okay with the customer. So this is our ingestion pattern. So we are going to use Databricks here as a data analytics platform in Azure. When we use Databricks in Azure, it's going to follow the Medallion architecture. Medallion is architecture is a three-layered data analytical framework where the branch is the first layer, which acts as a raw and immutable form. So you cannot update, you can, but we prefer to keep it as immutable. We don't want to change because we want to treat the data in branch as system of record. Source might not save this data for years and years, but we keep every record in branch forever. And then the next layer is silver. Silver is basically the transformation layer. So this is for the business purpose. So we include business logic here. We update, we use joins with different tables, and we format it. Most of the times when you are getting the streaming or events data from front end, either it come in JSON or in a nested different other nested structures. So all these nested structures, they are not easily readable. So what we need to do is we need to flatten them by using different Python and PySpark transformations, and all that logic you put or you write that in silver. And then the third layer is goal layer, which is for the business, for the customers who wants to use the curated data from silver too. So we establish star schema or snowflake schema in goal layer. So and then users can join their data from silver to goal, and then join with different dimension tables, and then make one big table which is easy for them to run some different reports on top of this data. So that is what gold layer is. So I would like to cover a couple of more topics here when it comes to Medallion architecture, because partitioning, as you know, in any distributed streaming processing or multi-parallel processing systems, we always use the partitioning concept. So I'm not teaching you what is partitioning right now, but in order to effectively handle the bronze and silver events, we always have to partition the entire data based on some event ingestion date, or maybe high cardinal columns, and the keys or surrogate keys, whichever makes you feel the right partitioning works. So we keep the raw data in bronze, and then in silver we apply the deduplication, because we don't want to maintain any duplicate records in silver. So that is why we apply deduplication concept to all the silver records based on merge statement. Nowadays in Spark structured streaming, merge is super important because it makes sure the record is processed exactly once. So in this, merge is called as upsert. Upsert is nothing but before you write anything to silver table, you look at the key, you verify the key. If the key matches, then it will update the record, and if the key doesn't match, it will insert the record. So this way it will make sure that the record is processed exactly once. And why we are using structured streaming from Databricks? Because this is ACID compliant. ACID compliant is atomicity, consistency, isolation, and durability. Your message will be processed once, always once, and however many times you update the same record, the result would be the same. And either you process the record, either the record will get processed entirely once or none. There are no partial updates to the records. So basically that is different layers of ACID compliant features. So that is why we use Spark structured streaming in Databricks here. And Going to goal layer, like I said, it is always analytics ready for the consumers or the business teams who wants to use the fact table coming from silver and then join the silver data with so many other dimensional tables and then make a big flat table and then use those measures and aggregations and individual KPIs pre-created or created through different measures in their reporting platforms, either in Power BI or Tableau. And what else we need to go? Okay, and there is a micro batch also. Sometimes instead of sending the data continuously to through streaming processing for 15 minutes of latency, we don't have to, make the latency 5 minutes or 5 seconds because we know it is going to be 15 minutes. So in these cases, what we do is instead of sending everything as it comes into the system, we kind of follow the micro batch here. Basically, what micro batch does is it kind of batches. Uh, you can choose this option, like, if you say micro batches, maybe some thousand files, then what it does is instead of continuously pulling the data and then processing it, it it makes the batches for first 1000 files and then process it and then wait for the next batch, and when next 1000 files are available, then it start processing that particular batch. So that's how we don't have to process is in 5 seconds or 5 minute or 10 minute, because ours is 15-minute latency. So in these cases it is always better to go with micro batch processing. This is a trade-off, right? So you don't have to run the pipeline 24 by 7 because that is cost expensive, and performance is good, and cost is more. When the customer demands the latency less than a minute or sub-millisecond kind of a processing, it is always better to go with that kind of a streaming. But in our case, the latency is just 15 minutes. So 15 minutes for this one, we don't have to waste the resources of compute and processing and everything. So the middle uh, path for this one is kind of a micro batches. So then now that we have ingested the data and then we have ingested the data using event hubs and then processed the data in a Medallion architecture in bronze, silver and gold. And then now the data is available in gold for both the business people and for the store manager or for the data scientist. Now we need to talk about how do we serve this data to these two kinds of user groups, right? So for store managers, what we do is you can ask them to use Databricks SQL Server or SQL Serverless, which is a Postgres SQL tables, wherein they can query the data and then start using or building their dashboards in maybe Power BI or in Tableau. So, and it is a 15-minute refresh or maybe 10-minute refresh to get that 15 minutes latency. That is a stop layer. And store managers are people who are sitting at the store level, maybe region managers or division managers. All these people, they have access to different reporting platforms, so they can start querying the data or look at the dashboards which are refreshed for every 10 minutes or 15 minutes. So that way they can see what happens in their store every 15 minutes, how many sales are going on, what is the inventory, and how much profit are we making, um, what are the different discounts that are being applied to different products. So everything within 15 minutes they can see or they can access. So that is for the store managers. And you go to data scientists. So we have the data ready. Store data scientists can use your bronze data, or they can use your silver data, or they can use your gold data. So they can use any of this data, because before I go there, I would like to also explain the Databricks Unity catalog here. Now that we have these tables or material views available every layer, like bronze, silver, and gold. So Unity catalog is a governance tool from a Databricks, a unified governance tool which takes care of both data and AI. Security and governance. So through Unity catalog, you can always look at your production catalog, schema, and development catalog and development schema, and start looking at each and every table. You can query them, access them, set up permissions on top of these tables. So there is always two sets of permissions that client is looking for in any organization the customer is looking for. So that is role-based access and then attribute-based access. Sometimes this particular roles, the business analyst, the store manager will only have access to these many tables, not the other tables. So that is role-based access. And attribute-based access. So some specific tables can be accessed by many people irrespective of their role. So in those scenarios, we go with attribute-based access policies. So that is the beauty of Unity Catalog. Unity Catalog is one governance platform or tool within Databricks that will serve different customers with their needs by giving access to them to the data that is being processed. So like same way, all these data scientists, they go and access the Unity catalog and fetch the information from bronze, silver, and gold table, and then they can run their models against this data, and then they find similarities and patterns in the data. And nowadays with the AI world, we have machine learning stores features available even in Databricks and then Azure and cloud, every cloud. So what they'll do is they use any of these existing options that are available to them, and then use this data to produce some semantic models out of that. So that's how both the store manager and data scientist will be able to access this data within 15 minutes after the data is generated or the events are generated. Sometimes what happens is uh, data needs to be shared within the organization, and sometimes the data can be shared outside of the organization. So Databricks provides delta sharing option to enable users to share the data between different organizations or different departments within an organization. So there are, we can cover a separate video on how delta sharing works in Databricks. We have two options there, Databricks to Databricks sharing, D2D sharing, and second one is Databricks to non-Databricks environment, that is open sharing. So let's not go there now. We are going to cover a separate video on that one. So, but the point here is the data can be shared between the systems, between the workspaces, and between the organization. That option is always available. So this is what the governance and security layer. So using Unity catalog. So I was covering the Unity catalog much before this slide, because we were talking about machine learning data scientists who wants to access the data. They have to access the data through Unity catalog. So like I said, Unity catalog is a unified governance platform within Databricks, which can allow permissions and accessibility to the data from different roles and user groups within an organization. You can do column masking in through Unity catalog. You can assign permissions. You can create resources that can be shared with different groups, and encryption at rest, encryption at transit. All these philosophies can be applied in Unity catalog. So that is why it is a beautiful governance and security layer within Databricks. So now we are receiving the data, and then we are processing it, and then we are cleaning it and then curating the data so that this data serves different purposes to different people within the organization. So that is there. We have done that successfully. But what happens if something fails in production? Or data is the latency has become more if the user is supposed to receive a customer data within 15 minutes but he is not seeing the data even after 1 hour. So how do we track that? So that's where the platform operations and observability layer comes into the picture. So you have to monitor your platform throughout the time, like when you set up the jobs, the pipeline jobs in workflows, like every job has to be orchestrated so that the data keeps coming and then it keeps refreshing, and then users will be able to see the latest data. So if you build the pipeline once and then just leave it like that, you don't those pipelines won't get refreshed and users cannot see the latest data. So in order for users to see or consume the recent data, we need to schedule or orchestrate these jobs in a workflow. So what that does is you can schedule the jobs for 24 hours or once in 12 hours or maybe every 2 hours or every 10 minutes or every 5 minutes. In our case, as the latency is 15 minutes, we schedule the jobs maybe for once in every 5 or 10 minutes, depending upon the load and storage and everything. Mm, so to monitor the platforms, we have different ways to do that. Within the Databricks, we have Databricks workflows where you can set up the jobs and then uh, set up the alerts to receive an email or to go to a Teams channel or use a Slack to get the notification. If job fails or if job is taking longer than it is supposed to, then you get an email notification or you get an alert or you get a Teams notification saying that some job is not doing well and you need to look at it. So that is there. And we have Azure monitoring services as well. If you don't want to use Databricks, we have Azure monitoring services as well to understand what is happening with the platform. And then if you are not comfortable with Azure, then you can also go with the third-party tools such as Apache Airflow, which gives a broader capabilities compared to, like in-house uh, monitoring tools. So you can do that. Um, you can always set up the observability dashboards based on the consumer lag and monitoring analytics and metrics and all that. So every log message is stored in the databases, either in Elasticsearch using Prometheus or DynamoDB or any database that can store the log messages. So based on those log messages, you can always create some dashboards and create alerts on top of those dashboards. And based on some pattern or some latency or some SLA, those dashboards can trigger alerts, and then these alerts can be reached to DevOps team or the developer or the quality team who is supporting that monitoring, and then they can take a quick action when they see an error or an alert or some call. So that is what the observability dashboard is. And when it comes to platform operations, we also have DevOps or CI/CD, continuous improvement and continuous delivery. So basically what we are talking about here is we're talking about GitLab or GitHub, wherein you can constantly make changes and keep the code repositories secure, and you maintain different layers when you make change to the code or a SQL query, and it can be your local branch, and then once the local branch changes are tested and ready, and then they can move to development, and then development to quality to production. With each and every stage, these requests will be approved by a supervisor when you create a merge request or pull request. So you have to follow all that process in order to make sure you maintain the entire platform smooth and running. So those are called DevOps and GitLab. And we also have Terraform promotion. Terraform is basically infrastructure as code, uh, or code as an infrastructure. So basically what it does is, instead of using the CLI, uh, command line interface for Databricks, or SDKs, what you do is you kind of write the script in Terraform ML files, how to create a cluster, how to create a workspace, and what kind of permissions it has, how the storage layers are enabled, and what kind of security permissions are we applying to the workspaces. Let's say, for example, are we keeping it as open, or are we keeping it as a private endpoint or private link, entire workspace. So all these parameters you can define in Terraform code, and then deploy the Terraform code so that you can set up the entire Databricks platform using the code, infrastructure as code. So that is what the Terraform is. So all these things are part of the platform operations and observability. So basically, in order to smoothly run a pipeline, all these things are mandatory and necessary, because if you just build a pipeline and then run it and then it fails, it no one really watching at it, then there is no point of building a effective pipelines, or data analytics platforms. So we have to have a team to monitor them. We have to have a team to configure, or change the configuration as and when needed, and we have to have a team or a system to support the CI/CD throughout the life cycle of the data and the operations journey. And then moving on to performance, cost, and reliability optimization. How do we make sure the performance is there in your analytics platform? So when we talked about the non-functional requirements, the customer said the system has to be available 99.99% all the time. That means you cannot take a risk of losing data. The system must be available across all the um, situations all the time, 24 by 7. So in order to do that, we need to do auto scaling, because scaling is nothing but when there is a load on the system, you can either scale it horizontally or vertically. So vertical scalability is something like your when you increase the size of the RAM, or when you increase the size of the disk, or when you increase the size of the configuration, that means it is a vertical scalability. So nowadays people are not very much inclined towards vertical scalability, because we are increasing the capacity of one machine, and which will eventually have a set limit. Horizontal scalability, another way, is like adding multiple machines with similar configuration, so that they can be spun when we need it, and they can be terminated automatically when there is no need. So that is called auto scaling. So we have to enable the compute workspaces in Databricks and set them to auto scaling. We can use cluster policies to set up these auto termination policies as well. And we can use Photon engine in Databricks, which is a high performed vector based engine, which does processing at mission critical speeds. So it is a little bit expensive, but at the same time the trade-off is it takes much lesser time to process your data. So performances versus cost, the trade-off is based on the customer requirement. And partition pruning, we always have to look at the partitioning. So you cannot keep more partitions to a less volume of data, or you cannot just keep a minimum number of partitions when your data is huge. So there has to be a fine balance between uh, more partitions versus less number of partitions, because partitioning partitioning is not expensive, but shuffle is expensive. Uh, when you have more partitions and when there is an aggregate operation, then shuffle comes into the play. Uh, Shuffle is an expensive operation because shuffle moves data from one partition to different partition. So they complement each other, both partition and shuffle, because when you have too many partitions, when there is a shuffle activity happening, and then it has to go to each and every partition and move the data from here and there, that's gonna take time and cost as well. So that is why the partition pruning has to happen based on the high cardinal volumes or proper keys and surrogate keys, or based on ingestion data, or based on a specific region, or based on a specific business type. So based on that, we need to think about a proper strategy to do the partitioning. So liquid clustering is the latest concept or feature in Databricks. Instead of we choose how to partition or how to z order the columns and everything, Databricks Spark itself decides how to make the partition, and then how to do the ordering based on metadata that is available in Delta log. So that is what the liquid clustering concept is. We can talk more about it in the upcoming videos as well. And in the Spark streaming, what it happens is the input when you read data from Azure Event Hubs, the event streaming data in the branch. So what it does is it creates so many Parquet files, like small Parquet files in Delta Lake. So and then on top of that, there is a Delta log file also will be there. What Delta log does is it records each and every transaction or update that we make as a record in that Delta log. So it doesn't delete anything. When you insert a record, there is a transaction log saves there. When you rename it, there is a transaction log. When you update it, there is a transaction log. When you delete it, there is a transaction log. So basically, Delta log is what makes this entire Databricks streaming processing as idempotent, uh, because however many times you do it, you'll get the same output, because behind the scenes the Spark streaming look at your Delta log and understands what operations have been performed, and based on that it finds the result, and then get it in front of you. So uh, so in order to have this efficiently process it, Spark structured streaming handles those small number of files versus big number of small Parquet files. So optimize is one of the options where if there are too many Parquet files, it tries to combine so many files into one large file, and then start giving it to structured streaming, so that it doesn't have to open and close each and every small file. With that, it kind of takes less time to process it. Because of that, performance will be more. That is what optimize is used. And then vacuum is something like, if you have been using the same a table or logic from a long time, there are so many Parquet files and the Delta logs are accumulated over the period of time. And if you don't want to go back maybe before 6 months, or maybe 100 days or 1 year in history, we don't have to maintain the Delta log for all of that. So vacuum, what it does is it kind of deletes all that information or metadata from the table, so that it creates some more space. That way you can save more data in it. So, and we covered about auto scaling. So in Spark also we have different clusters, on purpose, on demand cluster, all purpose clusters, which are like for development and testing, and job specific clusters, which are only used on a scheduled job. And then there are spot instance clusters, where it doesn't take much time to spin those clusters, and there are reserved clusters which are specific for routine ad hoc tasks. So choosing the right cluster for the right workload is also improves your performance, also saves some cost there. So that is, there is a trade-off between the performance and cost when you choose between these different clusters. So when you don't have to process 1 million or I mean 1 millisecond or sub millisecond or 1 minute kind of latency. You don't want to, spend more amount on these high performance serverless clusters, right? So and if the users, people or the consumers want to access the SQL warehouse with high performance queries all the time from your data, then we can refer serverless SQL warehouse as well, because the compute time for it is zero. It doesn't have to take much time to spin the cluster, or it doesn't have to take much time to terminate the cluster. They're available the moment you need it, and they'll be off the moment you don't need them. So that is how you choose to design which kind of the clusters you want, and what kind of termination mechanism you want to apply based on customer need and latency requirements. On the reliability, like I said, Delta transaction log will take care of each and every transaction, uh, the kind of update, the kind of work performed on that particular record. It saves all that information in the Delta transaction log. Using that information, Spark streaming handles the entire stream processing. So that comes under the reliability, because it makes sure the record is processed exactly once and it doesn't duplicate anything. And checkpointing is also there. So Delta, the one of the important things how Spark structured streaming work here is by using the checkpointing concept. Checkpointing concept, what it does is every time you read a record from branch, it kind of looks at the offset, like from where the last record was performed, and then it looks at that offset and then read the next one and write into the output table. So even though you replay the records and then the same record coming into the system again, it looks at the offset, and then if that offset is already covered and it doesn't process that record, it doesn't touch that record again. If that particular record is updated, then it follows through the merge logic, and then if it is updated, then it gets updated. It updates the record and then it saves it into the silver one. So basically checkpoint is used to handle the offset so that the data is not duplicated, data is not reprocessed again and again. So we have, even though it looked like a simple architectural pattern for this particular example, there are so many things that we covered, and there are too many trade-offs and alternative options also we have available here. So like I said, the customer has said 15-minute SLA. Let's say if he says sub-minute latency, that means it's a true continuous. We don't have to maintain the batches there, because micro batches takes a little bit of latency there, because every 5 minutes, 10 minutes or 15 minutes. So but if user wants the data in sub-minute or sub-second level, then micro batches is not an option. So we have to go for a true continuous option, wherein you have to go with the serverless computing, and auto scaling is at its peak, and performance versus cost. In that case, if the user wants a sub-minute kind of a performance, they may have to pay more for the serverless computes and everything, but that is okay. That is a nice trade-off based on the business requirement. What else? Databricks, Azure stack, Delta Lake versus multi-engine portability. So single vendor stack versus multi-vendor stack. So basically the trade-off is that. So single vendor track is when you don't have too many sources, when you don't have too many processing engines in your project, and if there is that kind of a requirement where you don't have to maintain multi-engine system, then you can safely follow the Delta Lake through Databricks, because a single vendor will always give you less overhead and smoother processing, and everything is in one ecosystem. So but your user wants a multi-engine portability, wherein, like, for this particular processing you are using Databricks, but there are Snowflake tables are there for a different pipeline, and then you would like to use those Snowflake tables, which are iceberg tables, in this system. Then probably you may have to go with multi-engine portability, even though the overhead is more, and the complexity around maintaining two processing engines is a bit kill or overkill. But if that is a business requirement, we have to go through that route. So that is the trade-off that we can manage here. So there are very many trade-offs that are available, that as an architect you need to make while designing or architecting a particular platform. Sometimes flexibility versus standards, like if you go through Unity catalog and want to maintain a proper governance, you need to follow the cluster policies and permission principles, and role-based access, attribute-based access, and if you have to share the data to a different organization, you need to follow through delta sharing capabilities, and you have to follow the protocol there in order to have fine-grained policies. But flexibility, on the other hand, the trade-off is like more controlled environment with a little bit of overhead to maintain these many things. But if you go with the flexible kind side of it, then you don't have to use Unity catalog, but always flexibility brings a lot of risk into the system. So that is kind of a trade-off that we need to decide based on, again, the user requirement. Every trade-off is based on user requirement. It is not a personal choice. It is not a technology choice. We always have to back this decision with the customer requirements. So now look at the overall thing that we did here, applied architecture principles. We have a business-driven architecture with SLA in mind, and they would like to have a single pipeline, because ours is a simple pipeline with not too many complicated events or multi-systems are coming into the picture. So, and we have a just two consumers, store managers and data scientists, and we gave them Power BI, Tableau, or feature stores to access this data. And secure by secure design, row level security, column level security. We can use enterprise SSO, intra ID, or Azure or IAM kind of a role-based accesses for the organization. You don't have to maintain separate access permissions for your data analytics platform. It's always safe to go by organizations SSO policies as well. And then we have done a lot of quality, data quality check in Silver, because the Silver is the one where we do transform. You can apply data quality rules there. Let's say, for example, if order number cannot be null, you can write that condition. If the order is coming as null, we treat that record as a malformed record and reject that record and keep it in dead letter queue, so that we can process them later or send them back to the producer so that he can replay them or correct it and then resend them. And we have a cost efficient AI ready platforms are available. So SQL serverless is one of those kinds. We don't serverless, see, with serverless versus regular compute, serverless you don't have too much of control because Databricks has that control. So but when you choose on purpose cluster job clusters of your own, you have utmost control on how you want to configure it, how we want to uh, apply security policies around that. So write data which is governed and deduped, governed through Unity catalog and deduped through Silver 1 and Silver 2 logics. And then write time, we always process the data within 15-minute window because that is the SLA for us. And the right place, so that the final curated data will always be available to the users via Power BI reports or feature ML stores in cloud or in Azure. And then right cost, match it to SLA. So your cost always have to depend on your SLA, service level agreement. So based on that, you need to frame the entire pattern based on your service level agreements given by the client or the customer. So that is what I would like to cover in today's topic. This is the first of the series. This is first one in the series. So what I'm gonna do is I would like to explain these architectures in simple way, and we keep adding complexity to each of these. In the next time, we will look at the similar architecture, but instead of doing Azure Event Hubs, I would like to bring in Kafka event streaming, because Kafka event streaming is an open source platform, but it needs its own set of environment within that ecosystem. So we would like to cover all of that in our next section. And then here we chose only one pipeline, both for store managers and data scientists. Let's say if store manager wants, I don't want to see the data for every 15 minutes. For me, once in a day is fine. Like, overnight in the morning when I come to the store around 8 o'clock, I would like to see a bunch of dashboards and then see what happened yesterday. So, and then, but data scientists are there, still they would like to see the data within 15 minutes. So for data scientists, the latency is still 15 minutes. And for store managers, it could be 12 hours to 24 hours. So in those cases, it's not possible to maintain the single pipeline because the latency requirements are different. So in those cases, how do we build the pipeline? Because we need to separate the processing here, batch versus streaming. So, and then we bring Kafka into the picture, and then we split the pipeline into batch and streaming. And then I can tell you how to design or what kind of things you need to make sure before architecting that kind of a platform. So I hope you like this video. And if you have any questions, please do comment, and I can do my best to respond to those questions. And if you like this video, please, if you really think that this video is useful to you, please like, and don't forget to subscribe, and keep watching this space for more and more videos and architecture patterns in future. Thank you. Have a great rest of the day.